All right, let's get started. It's feeling a bit cozy in here. Not too many of y'all showing up. So anybody who is here, if there is anything you want to see, please, actually let me start with that one. If there's anything you want to see, we can use this what to do for review post. If there's something you all want to see, I especially want to cater to those of you who are still showing up to lecture. If there is something, some reason why you want to be here, unless you just want to see whatever I come up with, that's fine too. But if there's something you want to see, let me know. We don't have a whole lot of activity on this post, and I'm open to just canceling lectures next week. Like if there's no demand, if there's no requests or anything. Ideally, if that is something you're interested in, you can just make a post and say, well, let's just not do anything. I got other projects and exams to study for. Let's just not even pretend to have lecture. If that's a suggestion that gets some traffic, I'll just cancel stuff next week. Instead of just going through this kind of agonizing, I don't know how it is for you, but it's kind of like I got to come up here and come up with something. And I don't really want to resort to just reviewing the whole semester, which I can do. Again, if that's suggested, I can do that. But we're in a state where there are requests to cover large chunks of material, but then either 0 or 1 upvotes. And if it's just one person, I mean, you can come to office hours and we can talk. I only had 2 students in office hours yesterday. I'd be happy to talk about whatever you want in office hours, but I don't know if we have to have a whole lecture to cover something for 1 or 2 students. If there's more traction on any of these, I'll be happy to. Do you have a question? Suggestion? Anything? I thought you had your hand up. Right? For today's review session?
Yeah, I just wanted to ask a question for those who about AO2.
Yeah.
I didn't understand for this project AO2, what is going on?
What's going on with AO2 for this project? Yeah, I can do that. All right, so, and this one, I don't even know if I should talk about this in lecture. It might just come off as ranting, but I have 3 posts here that all mention recursion, but I know for a fact that the other 2 people didn't both upvote the third one. Like if you want recursion, but you're not even bothering upvoting. There are some differences here. Like, is it really I want recursion in this way or this way? I don't know. But if nobody's using the posts, I'll just take that as nobody's interested in these last 2 weeks of lecture, which is perfectly fine. We can just go do other things. I'd be happy with that, and just call today the last lecture. I'd be happy with that. I'll come back to this post at the end of lecture if you're communicating to me through that post. We'll go off of that. I updated my phone, and it won't connect to UB Secure now, so I'm not seeing live chat. I gotta switch to my frickin' mobile data. Just give me a sec. I switched to my damn mobile data to be able to see chat at all. Google Fi, back to Discord, connecting. Hey, there we go. I was wondering why Dragos didn't say hi. What's up, Dragos? What's up, Dragos? What's up, Dragos? What's up, Dragos? I'm noticing a trend here. All right. Okay, so let me do a couple more things. The course evals, I'm updating this post as we go. I thought nobody was chatting either. I'm like, what is going on today? Okay, I'm feeling a little better that there's some life out there. So the response rate, we're getting close to that genetic algorithm. Let's check the exact numbers. That's a little stale. Evals. I was getting worried I was just talking to myself up here for the most part. And we're still sitting at 54. So 54, I'll probably send out an email at some point. Through the eval system, I can send I think I only get one shot at it, but I can email only the students who didn't already submit. So hopefully, so we should see a good burst once we hit that. Once I send that email out, maybe I'll send that out this weekend, because time is kind of a factor. I'm only opening this for one more week from today till next Friday. So we got to hit these percentages soon so you have some time to work on those. But I am updating this. This is live. We're at 54. You saw it right here, 54. So we're getting there. We're getting close to that 60 to unlock genetic algorithm. Hopefully we can get to that 70 at least. I think it's reasonable to get to 70 in 116. 116 usually has lower response rates, but 70 is achievable. The 80 is probably out of question, but most of you have pale blue dot anyway, so I'm not too concerned. And there was demand last time. Make sure it's still running. Oh, I ran it in the background. So I did redeploy. Oh my goodness, I'm not logged into the server. The app that we saw last time, the Zombie Rush game. Y'all want to see it? We're going to see it. So I went to the server, made sure it's started. Created about an hour ago. That all looks fine. And here, hopefully it works. This is still in development, so I won't be surprised if this crashes. Where am I? And when you go to that site, we have a self-signed cert, so you will get a security warning. It'll say, hey, are you sure you want to do this? If you don't trust my self-signed cert, that's your choice. But it's legit. Like, it's fine, it's encrypted and everything. But we have a self-signed cert on the HTTPS. So you move around, you can, I always forget what button it is. I think it's the left mouse button and drag around to look around. On a touchpad, you do a two-fingered touch, or you accidentally do the shortcut to go back. Opera doesn't let you go to self-signed cert sites anymore, so I got to go to, oh my goodness, did this crash immediately? It is still filled with bugs, so I wouldn't be surprised if it crashed immediately as soon as a few of you joined. But let's try to get this cooking. Advanced. Accept the risk and continue. Okay, there we go. So I think it's right click on the. I've been testing on the touchpad. I use a two-finger click to look around, WASD or the arrows to move around, and then click. It must be right click to look around, and then click to fire. And there we go. We've crashed already. God damn. I just saw this bug before lecture too. I thought we fixed that one, but this is the game. Y'all wanted to see it. That's the idea of it. This is where we use the states. If I can get this restarted, we should be able to see the states. When the game first starts, you're going to see up in the corner here, you're going to see the countdown between waves. That's when we're in that between waves state. Give it to me. Give it to me. Come on. This is like a pre-alpha thing, so we expect a lot of bugs here. So we're already past that timer. But if we kill these enemies, and the game lasts long enough for us, and this is our spaceship. This is the tower that we're defending. And well, I don't get to show much, but you get the idea at least. And when we're in that game, in between states, in between waves state, I can't even think anymore. It's been a long semester. You'll see that countdown in the corner, and then once a wave is deployed, I swear I fixed this bug right before lecture. But once a wave starts, we're going to switch states have a state transition to be able to actually have the wave running. I want to know why that bug came back. Anyway, well, if I stare at this, I'm just going to get in debug mode. I don't know if that's the best use of our collective time. But this, right now, we're between waves. Okay, yeah, there we go. Now we can see it in the corner. We're between waves. We're in a different state. As soon as that timer clicks down, all the monsters spawn back, and we're on the next wave. And we're Russian zombies. So we have this set up to be able to be used with the keyboard, so you can play like this. But that's not the intent of the game. That's not really the selling point of this game. Oh, my. The idea here, and we're about to get ambushed here, the idea here is that this is going to be an augmented reality game where you're actually holding a physical plastic, fake, but a physical gun with a tablet on it, and then you're walking around in the environment seeing this world on the tablet, then you're actually aiming and shooting at the zombies. That's the idea of this game. When you see these tags here, these poles, these will relate to physical objects in the real world, which are detecting your location. So as you're moving around in the real world, you're moving around in the game world. We're getting the actual AR, augmented reality. So we have a spot set up where we do have the actual tags in the ground. And I don't know, it's really fun to play in that area where you're actually in this world being attacked by zombies. And there's gameplay improvements that we're constantly making. We got a lot of bug fixes before we get there. But this is the idea. This is the game. So this is the code that I was showing on Wednesday as part of this game. And it's going fine now. I wonder what... I have to check all the logs and figure out what was going on earlier. And that was an enemy base that's spawning these guys. We killed it fast enough that it didn't spawn too many. Eat projectiles, zombies. And this wasn't working earlier. There are 3 different attacks, but for some reason, this latest update that we had, it constantly goes back to fire projectile. I don't know why. I'm going to blame my brother, because he's not here to defend himself. But yeah, that's the game that me and my brother are building. Actually, both my brothers. My other brother's an encoder, though. He's been doing a lot of the networking side of things and the hardware side, getting those tags set up in that system. So this is kind of our side project. We've been having a ton of fun with it. And since I used it for a lecture example, I figured I'd at least show what the game is. So there's that. And you do have health. Right now, once you run out of health, you just respawn in like 5 seconds. There's not much penalty for dying, because for testing, it's no fun to just sit there dead. And you can hurt each other. Eat shit. God. Oh, well, our base is dead. I'm not going to sit here and hit it 100 times, but you can kill your own base. There's friendly fire. Oh, my mouse was off the screen. All right. Jesse 2021. So that's that. So for those of you who not played, I don't want to just have you sit here and stare at us playing the game. So with that, is there anything anybody wants to see that hasn't been discussed yet? Okay, we did that. We did that. In my mind, I'm just trying to wrap up the semester. I'm making sure there are no loose ends, making sure we're talking about everything. What to do for review. Nobody posted anything extra. Maybe I should just do a poll. How many of you want next week's lectures just flat out canceled? None of you? Okay. How many of you want to come here next week and just see whatever I come up with? Okay, well, I guess that's definitive. All right, I'll just come up with random stuff. I'm fine with that. All right. All right, so I'm going to knock out these. I mean, I'm not going to do everything here, especially with 0 upvotes. But recursion shows up 3 times, so I have to assume at least 3 people want to see recursion. So I'm going to go into the examples repo. I'll find a recursion example, run the debugger, and go through that. If that sounds all right. Did I go through towers yet? I didn't do this either, so that'll be next week. All right, yeah, I can fill up this. I can come up with stuff. So I was prepared to talk about towers. I'll still do that. How I actually deployed towers out onto the internet. I'll show you all the setup and configuration for that. I'll do recursion examples today to wrap up what has been suggested, and then next week when I'm just making up stuff, I'll show you how I deployed towers to the internet. And I guess I could do it today. I owe you more talk about the final exam at some point. If we were canceling next week, I would have just done that for the rest of today. I could still do that, but let's do some recursion first. So programming, recursion, and let's do anagrams. Cowpuncher's melting my CPU right now. Hold on their laptop. I don't believe you that you're running 0 CPU. All right, so recursion. I brought up this anagrams example a few times before. So let's go through this again. Let's go through it with the debugger. I think I only briefly showed it this semester. It's a fairly complex example, so when I show it in the middle of the semester, like when you're first learning recursion, it's a bit much. But at this point, and especially for those of you who are still showing up to lectures, I think you're ready for this stuff. So let's talk about anagrams. I'll set my breakpoint. Where do I test anagrams? Let's do something with double letters. We'll do anagrams of off. So to refresh your memory, the anagrams, given an input word, give all the anagrams of that word. So for off, all of the anagrams would be off itself, FOF, and FFO. So my method, if it's doing what it's supposed to do, should return those 3 strings as the anagrams. So let's run this thing in the debugger. And we talk about, I'm trying to comprehend all your tangent stuff. Like, I kind of get what you mean, but was everything upside down? Use loops unless recursion is faster. So when to use recursion versus when to use loops is an interesting question. My short answer for it is it's personal preference. Like, if you're comfortable with recursion, you like it, go for it. If you'd rather just stick with your loops, go for it. There are some exceptions. The big exception is when you're working with trees. Anything with trees, there's a natural, recursion is just natural for that. I have my challenge in the trees lecture. Try to write any of the tree traversals without using recursion. It's a pain. It's very painful to write. It's possible, you can do it, but it's hard. So if you don't believe in recursion, if you're sitting there thinking there is 0 place where I would ever want to use recursion in my life, try rewriting one of those tree traversals in order, post-order, pre-order. Try to write those without using recursion. It's my challenge to you if you're a non-believer in recursion. So that's one case where recursion is just really helpful. And the reason recursion is really helpful in those cases is because you're using the program stack to be able to track what has been done and what has not been done. So when you're going through this recursion, whenever you revisit a stack frame, you're revisiting it at the line that it was waiting on, at that recursive call, and then it knows what else it still needs to do, if that makes sense. Actually, let me pull up the code. It'll make a lot more sense. So like if we have an in-order traversal, and on the root, I call in-order traversal, and then on the left node, then on the left node, I call in-order traversal. On the left node of that, I call in-order traversal. Finally, we get to null. This returns. And then I get to this. I make an in-order traversal call, and that one returns. The big question we have, if you're doing this in a loop, is when you revisit a node after a recursive call, and you go back to a node, where were you? Where did you leave off? You either left off at this recursive call, and that's the one returning, and you have to call the function and then the second recursive call, or you're returning this recursive call and you're done. Done with this recursive call, and you can return. So that's a big question. Whenever you return to a node after a recursive call, which recursive call was it? So if you're using a loop, you have to remember that. You have to have some data structure that's going to remember all of that information to remember where to return to, what still needs to be done, and what was already done after that recursive call. That's difficult to do. Possible, but a lot more painful than 5 lines of code. And one of those lines is a closing brace. When you're using recursion, the program stack is going to remember that for you. So when we leave off at this line to make this recursive call, once this recursive call returns, program execution returns at this line, this resolves, and it just moves to the next line. Makes this recursive call. When that recursive call returns, we just pick up execution right here and go on to the closing brace and then return. So the program stack is remembering where you are, where you left off after each recursive call, so you don't have to. So what you're doing is leveraging the program stack as a stack data structure with a bunch of information in it with these program pointers, remembering where your execution left off for each stack frame. So that's really, really helping you out, really benefiting you by using recursion, because you can take advantage of that stack and the idea that all these frames are on the stack in a very specific order, and each one not only has its own variables on the stack, but something I didn't talk about, at least by name, it has a program pointer, which is remembering which line it's waiting on for a return call to be able to resume execution. If you're writing one of those traversals without recursion using loops, you have to build that data structure, which is probably going to be a stack of some custom type that you create, which is going to remember that information. Where am I? Where did I leave off? And then after you're done executing something, you're going to pop off that stack. That stack's going to have some object that says, you were on the second recursive call, or you were on the first recursive call, and then you're going to have code based on which recursive call just returned, where you're going to pick up execution. Now, we didn't have the same problem with linked lists because there was only one recursive call. So after the recursive call, you know where you pick up executions after the recursive call. When there are 2 recursive calls, you don't know which one just returned. You don't know which one you're on. Makes it a lot tougher. So I'd say personal preference until you get to trees or anything with that similar structure where there's multiple recursive calls naturally. Oh, I'm already running this. And use loops unless recursion is faster. They're comparable. I mean, unless you're using loops or recursion very irresponsibly, they're going to be asymptotically the same at the very least. And recursion could actually be a little bit slower because you have a lot of extra memory that you're adding to the stack. that can be slightly more inefficient. So it really depends on the application. But usually recursion is going to have more overhead, but not to a degree that you're really going to notice. And if you use tail recursion, you don't have that overhead anyway. If you're not using tail recursion, then your recursion's pretty unreliable anyway, because if you get to like 1,000 frames on the stack or so. Actually, let me step through this and then we can play around. We can play around with recursion. I mean, it was asked for enough in the things. Let's just play around with recursion. So we have an input of off. And just a quick reminder of the idea of my algorithm here. I'm getting an input string. I'm going to check, is the length of the string 1? I really should do less than equal to 1, just in case somebody gives me an empty string. Oh my goodness, that's not how you do things. Just in case somebody gives me an empty string. So is the length of this string 1? If it is, this is all of the anagrams of itself. If you give me one character, I can't rearrange that character in any way. This is our trivial input-output behavior. This is our base case. Base case is something that is its own anagram. Just return a list containing that anagram. If you give me just the letter X and say, give me all the anagrams of this thing, I'm just going to return a list with the string containing the letter X. Easy day. It's the recursive step where we have to do some work. So I have some logic here, and the idea of what I want to do here is if I have a string that's not length 1 or length greater than 1, what I want to do is I want to end up making a recursive call that's going to be closer to the base case. And something I didn't really stress, I think next semester I'll word it this way, is when you're writing a recursive algorithm, your goal is to make a recursive call that's closer to the base case and have all your logic surrounding that make sense. That part I said. The part that I didn't say is your goal should be to do the minimal amount of work possible to be able to get one small step closer to the base case. So the minimal amount of work possible, if I have a string of length greater than 1, I want to try to get it closer to length 1. The minimal amount of work possible is to address one character, get a recursive call with length n minus 1. I want to handle one single character in this string, and I make my recursive call. Just like for processing the songs in LT4 of genetic algorithm, to processing the songs, your goal is to process one single line of that file. Your base case is no lines to process. You want to get closer to that base case, do the minimal amount of work possible to get closer to the base case. That's processing one single line. You process one line, make the recursive call, good to go. So my goal here is to get rid of one letter, one character, and then make the recursive call. So my next question is, well, which character do I get rid of? If I get rid of one character, say I get rid of the first character, and then I make a recursive call with the remaining two characters, and if that returns all of the anagrams of those two characters, then what I can do is append the character that I removed to the end of all of those anagrams, and then I'll have all of the anagrams with that character that I removed added to the end. So I'm going to make a recursive call with all the remaining characters, make my recursive call, and then I'm going to append the character that I removed to the end of all of those anagrams. So if that did give me all of the anagrams with that character removed, then with the character added back in must be all of the anagrams of that plus that character that I removed. Now the question of which character, why did I just pick the first character? Well, I'm not just going to arbitrarily pick the first character, I'm going to pick every character. So I'm going to repeat that process with all three characters. I'm going to remove this character, get all the anagrams with the recursive call, add that character back, remove just the second character, get all the anagrams of OF. Once that returns, I'm going to append that F to the end, and then get all the anagrams of OF again with this F removed, and then append the F to the end. And once I combine all those, then I'm going to get all of the anagrams of the original input, and I can return that. So I'm going to, where am I? What am I doing? I'm going to step through this thing. Things get a little strange in the debugger just because I have so many anonymous functions and stuff going on with trying to cram this all in like a line or two here. So the stack frames are going to get a little wonky. But we can start seeing, we just made a recursive call with the first character removed and FF. And we can go back to our other recursive call where the input was OFF. So we made a recursive call with FF, which is going to make a recursive call. Just skipped over half my stuff. Where are all my buttons? I want to get to the base case and show what's going on. So eventually we'll get to the base case with an input of F, which we're just going to return that list, where we have another call of OF, another call with OFF. So we're making recursive calls down by removing a letter, removing a letter, removing a letter. Eventually we get down to our base case, which we're just going to return, and then append return. Oops. Get me out of there. Get me out of this too. Get me out of this too. And eventually we're going to collect all those outputs. It's kind of hard to step through this one of the debugger because I got too much going on a single line. But eventually we're going to collect all of those values. Why are you going into range? I'll just talk through the code. Eventually we're going to collect all those values, flatten this into one single list, and then remove all the duplicates with distinct. But the important part is seeing these stack frames. I have a stack frame here, input, stack frame here, stack frame here, to see all the recursive calls going down the stack. Ooh, yeah. Yeah, they're interchangeable in this class. So what's the difference between saying code and algorithm? Yeah, in this class, it is the same thing. So an algorithm is independent of the code. So I could talk to you about the breadth first search algorithm. Like when I cover it in the slides, and I'm just using like diagrams and explaining how breadth first search works, that's the algorithm itself. So that's what the algorithm is. As soon as I type that in code, I'm implementing the algorithm in a program and implementing it in code. But the idea, the steps that you take, the kind of recipe that we're following, that's the algorithm itself, and that's independent of any code. And then we could take one algorithm, implement it in Scala, implement it in Python, implement it in JavaScript, implement it in C, and that doesn't matter. Hell, I could implement it with the dancers with the video. I'm blanking on the details, but we could stand up here and like simulate. I'll stand in a row and simulate merge sort by moving around and like sort ourselves by age or something like that. That's still an implementation of the algorithm. So the code is taking an algorithm and then coding it up. But in 1.16, I usually use them interchangeably. This is my implementation of the algorithm. What I'm verbalizing to you when I'm explaining this thing, that's my algorithm, and then this is my implementation in code of that algorithm. Good question. The distinction will become very apparent when you take literally named algorithms 331. All right. I think I'm done with that example. Is that what y'all want to see? Like, there were 3 requests for recursion, but I don't know. I feel like I covered recursion a lot this semester. Is there something specific? Because if I just go over it the same way again, I don't know if that's helpful. But if you have something more specific. It's recursion, tracing through a program. Oh, and actors. Actors, I guess because this is probably someone who has to do LO3 quiz again. I would assume. Which that one I didn't talk too much about. So here's an example I didn't go over. This is, as it says, traffic simulator. So I have two different types of actors, intersections and cars. And cars travel between intersections. Intersections have a northwest lane and an east-west, north-south lane and an east-west lane. And then there's a stoplight that can either be green for east-west or green for north-south. And then cars can approach an intersection at a certain direction. And then if it's a red light, they got to wait. If it's a green light, they can go. And I had visions of making a GUI for this and being able to visualize everything. I never got there. Maybe someday that'll happen. I actually made this a lecture question a few semesters ago, which turned out to be a mistake because there's a lot going on with this thing. But we can talk about a few at least. I don't want to go through this whole thing, but a few of the messages. So like when an intersection receives a message from a car that says, "Hey intersection, I'm approaching you from an east or west direction," the intersection is going to respond with whether or not they can go. The car is asking the intersection, "Can I go?" effectively, and the intersection has to tell them whether or not they can. So if they have a red light, we're not going to respond with anything, at least not yet. And we're going to add them to a list, which is the cars who are in the queue for either east or west. If it's not red, then it must be green, east to west. And we're going to tell them, "Hey, you got a green light? Frickin' go. You can go right through this intersection." When the car gets a green light message, so when the car receives a green light message, it knows that the intersection that it's approaching is a green light, and it can blow right through. So once it receives that message, either that or it's been waiting in the queue and got the green light to go, once it gets that message, it has directions that it's following, which is a list of intersections. It's going to go to the next intersection. It's going to get to the next intersection and update its directions to remove that intersection. So what's the next intersection in my route? And it's going to head to that one, and it's going to send itself that direction, which when it receives, actors can send messages to themselves. So when it receives that message from itself, which should be almost immediately, it's going to read that direction and then wait however long it's supposed to wait, or however long, I shouldn't say wait, but however long it takes to travel to the next intersection. In that amount of time, it's going to send itself an approaching message, which says, "Hey, I'm approaching this intersection from either east-west or north-south." This is a Boolean, so if this is false, then it's north-south. When it receives the approaching message, it's going to send a message to that intersection, which says, "Hey, I'm approaching you," and the intersection should say, "Hey, I'm red," or "Hey, I'm green." The intersection is going to be on a timer and change its light at fixed intervals. Whenever it changes its light, it's going to go to all of the cars who are waiting in the queue for the direction that just turned green and send them all the green light message and then empty out that list. Same thing for north-south. And then once it changes, it's going to invert the light. It's going to switch the light and then send itself a change light message in whatever, what is time interval? Do I fix this? Oh, I take each intersection has different time intervals. Then it's going to wait for however long that light is supposed to wait to change, and it's going to change again. So when I create this thing, each intersection is going to have a different amount of time. Like this intersection is going to take 10 seconds before changing lights. Every 10 seconds, it's going to switch its lights. And we don't have any yellow lights here for what it's worth. As soon as one light goes red, the other light's green. So there would actually be a lot of accidents at these intersections, but hey, we're not looking for accuracy. And then directions, this car is going to go through intersection 1, then 2, then 3, then 4, and these are the the times it's going to take. 5 seconds to get to the first intersection, then 3 seconds, 8 seconds, 2 seconds. Add 3 cars that are all following the same route. Add another car following another route. And let's run this. I think I have a whole bunch of output that I print to the console. Yeah, to show what's going on. That's super interesting output. But it shows like when the cars are approaching each intersection, they'll follow their paths. The lights will change. Those 3 cars will queue up because they're all following the same directions. And then they'll eventually all make it to their destination. So I'd like to visualize this someday. I haven't gotten to it yet. But if there were another homework where I give you a GUI where you actually see the cars moving around in a traffic simulator like this, and then you could like program your cars. This is where we could do pathfinding too. I might replace homework 4 with this. We could do pathfinding with intersections that are actually like finding directions instead of moving through the game. Give it just a different flavor. And play around with actors. I might hide all the actor stuff like I do with homework 4 now. But you could code how a car behaves in traffic, and then be able to see the visualization of how your simulated cars, your AI cars, kind of move around in the environment. Maybe we could even do something cool like programming our AI to reduce gridlock or something like that. How to have efficient cars that'll, move through a city without jamming everything up. All right, so that's actors. I think that was asked for up here as well, somewhere in here. No, immutability. Where we at? 7 minutes. Pale blue dot hint. Oh, we're supposed to talk about AO2. Sorry about that. I gotta talk about AO2. So there's quite a bit here I can actually talk about because I can explain, not genetic algorithm. Oh, did I not? Oh, there it is. I was going to say, did I not clone it here on this laptop? There's a bit I can talk about here because I can just explain the code that I gave. So your decision tree, I gave you this sample decision tree, partly so when you finish LT4, you can actually see your AI doing something, but also so you have something to go off of for AO2. So for this, I want to create a decision tree. I'm going to create 2 different nodes. One is going to be the root node, which is going to just roll the dice, and if you happen to get a roll less than 0.1, so a 10% chance, you're going to fire. Otherwise, you're going to hunt the closest player, move towards the closest player. So for this, I'm creating a decision node, which a decision node takes a function which takes the game state and returns an int. If that int is negative, we're moving to the left, like you'd coded in LT4. If it's negative, we're going to the left. If it's positive, we're going to the right. If it's 0, then this node is the deciding node. So I'm going to say if we hit that 10% chance, we're going to the left. Else, that 90% chance, we're going to the right. So it's completely random. If you call this function twice in your LT4, you're going to see strange behavior in your GUI. Your AI is going to be kind of wonky because you're rolling the dice twice, and sometimes you'll get 2 different values. So if the first time it's -1 and you're checking if it equals +1, roll the dice again and it's 1 and you're checking if it equals -1, then you have your else. Your else is actually going to be hit in that case. So it's a strange bug. I see it every semester, at least a few times. So here's the function. And then where are we looking? Decision node. No, this is a decision tree. Oh, I'm looking at binary tree. So we're creating a binary tree node of decision tree value. Decision tree value is either a decision node or an action node. In this case, it's a decision node. So this is the entire decision node. Let me do it like this. And then the binary tree node, its value is this decision node. Its left child is fire, which is another binary tree node, and its left child is hunt closest player, which is another binary tree node. So when I create this binary tree node, value, left, right. So this is the root to my tree, is this decision node, which is just rolling the dice and figuring out, are we hunting the closest player or are we firing at them? If we're firing, if we go to the left in this tree, we're going to hit a fire node. This is going to take a function that takes the AI game state and returns an action for the player. What action is this AI player going to take? And since this is a fire node, that player is going to fire. It's going to fire at this specific player is going to fire. So they're not going to aim at all. They're just going to fire in the direction that they're moving, which should be towards the player, just coincidentally. Should be towards the player. And then null, null for right and left. So this was an action node. So an action node always returns 0 for check, meaning this node, you should take the action method, call the action method, and then call whatever function it has, which is the function from the constructor, which for this one, the function, let me separate it out here. The function is this. Is this function. For this case, we're going to take the game state and just fire. Now I saved the most complex one for last, of course, intentionally. So for a hunt closest player, if we went to the right, if we got that 90% chance, we want to move towards the closest player. So again, we're an action node. It always returns 0 for check. So in your LT4 code, you're going to get the 0, and you're going to say, okay, this is an action node. Call the action, which calls the function, which is the function from the input, and that's the action that's going to be taken by this player. So for this, we have this function, which is going to take the game state and then start calling your code from the other objectives. It's going to get this player by ID by calling your locate player method. It's going to find the closest player by calling your closest player method and using that game state in both of these. So you're going to pass the game state to these methods that you got in this function, that you're going to get from this function call. Get the closest player, find the path, again, calling your methods that you wrote in other objectives. Get the path from this player's location, this AI player's location, to the closest player. And then finally, call your path to direction method with that path that you computed to get the direction that this player should move. And finally, the action that you're returning is that move player in this direction. So when we're at 240, maybe I should just leave it at that. Let me see if I'm missing anything big. That should be enough for you to be able to do the thing. But let me make sure I'm not missing anything big. But you have to take that game state input and use that for all your computations. And that AI player, here's the behavior, so you have to find the closest player, the distance of the closest player, and then make some decisions based on that. So your decision nodes, you're going to have more than just one of them, are going to make decisions based on the distance of that closest player. And that's how you're going to decide whether to go left or right. And you're going to end up at either a node, an action node, where you're going to return stop, an action node where you're going to return move player towards that closest player, very similar to the move player that's already in the existing code, very similar to that except you want to use your LT5 and 6 code, or your AO1 code. And then finally, less than 5 tiles away, that's where we're going to shoot at the player. We're going to fire with direction, and we're actually going to aim at that player by taking the 2 player locations and subtracting, just like you did in the path to direction method. You're going to do some vector subtraction and fire directly at that player with fire and direction, instead of just fire. So hopefully in there I covered any question you might have had. We're not looking for accuracy. Does anyone know what level width is? That's the entire width of the level. So like that would be this entire width. And the important thing with level width and level height, make sure they're large enough to fit all of your test case in there. Because if you have like walls or players that are outside of the playable area, which is what level width and level height are defining, everything is going to break with your testing. Make sure level width, just do level width and level height of large enough values to cover everything that you have in your test case. I saw that mistake in office hours, just not setting them at all. They default to 0, 0. So if you don't set those at all in your testing, everything's going to break because you have a level that's size 0, 0, and anything that you put in your test case can't fit in a board that's 0 size. So make sure you're setting level width and level height in your test cases. But that would be the width and height of the actual board itself. All right. So have a great weekend. I'll see you Monday.